Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. So in this question, we basically need to add the 2 3/4 and the 2 2/5. So we're going to do 2 3/4 plus 2 2/5. Now, if I just rewrite this, 2 3/4 can be written as 2 plus 3/4 plus 2 plus 2 1/5, or 2/5. So we can add the two 2's together to make 4. And then all we need to do is add the 3/4 and the 2/5. So when you add two numbers with different denominators, what we need to do is get the common denominators. And we do that by just quickly writing out the 4 and the 5 times table and seeing what the first number in both their times tables is. 16, 20, and 5, 10, 15, 20. So that's 20. So we need to get the bottoms of the fractions to 20. Now for 3/4, to get the bottom to equal 20, we need to times the 4 by 5. And whatever you do to the bottom, you've got to do to the top, so times that by 5 as well, which will be 15. And for 2/5, we'll get that bottom to 20, so we times that by 4. And so we've got to times the top by 4 as well to make it 8. So it's going to be 15 over 20 plus 8 over 20. So we need to add the numerators. So it would be 15 plus 8, which is going to be 23 over 20. Now that is a top-heavy fraction, so we can rewrite that as 1 and 3/20. And we can add the 4 and the 1 together to make 5 and 3/20. So the answer is 5 and 3/20. Whenever we do these kind of questions, it's always best to convert the pattern into numbers. So we're just going to count the dots. So we've got 2, 4, 6, 8, 9 in the first one. 2, 4, 6, 8, 9, 10, 11, 12, 13. 14, 15, 16, 17. So our sequence is going 9, 13, 17. And we're going to see what it's going up in. So we're adding 4 each time. And that means our sequence will involve 4n. And then what we do is we go backwards 1 to find the 0th term. So we're going to take away 1. So 9 take away 1 is 5. So the 0th term is 5. And the 0th term just tells us what to add on to the 4n. So 4n plus 5 will be our answer. To find the pressure, we need the area and the force. And we're given the force in the question, and so all we need to do is find out what the area is, which will be the 7 times the 9. Which will be 63 centimeters squared, and the force is given to us in the question. So what we can do is write down the pressure formula, which says that pressure equals the force divided by the area. Force is given to us as 2268. The area we've calculated is 63. Divide the 2 and you get 36. So it's going to be 36 newtons per centimetre squared. So it's really important, first of all, we make clear about how we convert things. So if I've got a unit in kilometres and I want to convert it into metres, then we know we just times it by 1,000. So 2 kilometres is 2,000 metres. But if I have something in kilometres squared, and I want to convert it into meters squared, I actually times it by 1,000 squared, which is 1,000 times 1,000. Okay, so I'm actually timesing it by not 1,000, but 1,000 squared, so that's another 3 zeros. You can see here that that's 1,000,000, so we times it by 1,000,000. So 13 kilometers squared is going to be the 13, and then it's going to be times by 1,000,000. So 1, 2, 3, 1, 2, 3. So it's going to be 13 million. Now, it says here the farmer must pay 1 pence tax for every metre squared. So this is going to be 13 million metres squared. And so that's going to cost him or her 13 million pence. But the answer is going to be in pounds. So we just need to get rid of 2 of the zeros at the end. So it's going to be 13, 1, 2, 3, 4. So it's going to be £130,000. The important thing to realise in this question is that we know a female has been selected. So we can just basically get rid of all of this part of the frequency tree because it's not relevant, because we know a female has been selected. So there's 29 females altogether, and we're looking for the probability that the female chosen at random picked action. So it's just simply 16 over 29. We're going to start by looking at the numerator and the denominator separately. So looking at the numerator first, we've got 9 to the power 16 times 9 to the power 46. Now, when you have 2 powers of the same base, so they're both 9, base 9, but base is the big number, then what you can do is you can add the indices. So we're going to do 16 plus 46, which is 62. So it's 9 to the power of 62. And looking at the denominator, well, you've got a power inside and outside the bracket. Whenever you have that, you can just multiply them. So it'd be 9 to the power of 40. Now, whenever you've got a division between 2 powers of the same base, which we have here, it's 9 to the power of 62 divided by 9 to the power of 40, we just take away the indices. So it'd be 62, take away 40, which will be 9 to the power of 22. So our answer is 9 to the power of 22. So to find the gradient, we need the formula or the equation in the form y equals mx plus c. And the m there will give us what the gradient is. So we're just going to be rearranging this equation. And so I'll get my lines in. So the first thing I'm going to do is get rid of the x's from the left hand side, and we can do that by adding 6x both sides. So we've got 6y equals, and I'm going to put the 6x first, just to match the y equals mx plus c. Right, the next thing I'm going to do is get rid of this 6, because we just want a y there. So we're going to divide by 6 both sides. So we've got y equals 1x plus 36. Now we shouldn't really write 1, but because we're looking for m, we're looking for the number before x, I've kind of left it in there to show that the gradient will be 1. On a scatter graph, an outlier is a point which doesn't fit the pattern. And as we can see here, all of these coordinates fit kind of a nice line going down there. So they all are showing a trend. But we've got this point here that's nowhere near that trend at all. And that's what we call an outlier. So we know that these are going up in 2s. So this will be 28. So the x coordinate will be 28. And this will be 19. So our coordinate will be 28, 19 for our outlier. So I'm going to write this out again just to give us a bit more space. And the way we're going to solve this is exactly the same as if we had an equation there, well, with an equal sign, obviously. But with this one, if you times or divide by a negative, you've got to flip the sign. We're not going to be doing that in this one, but that would be one of the differences. So we're going to take away 10 both sides to get 7x on the left-hand side. Make sure you don't put an equal sign in there, otherwise that is instantly 0 marks. Then we're going to divide by 7 both sides to get x on its own. So it's x is greater than or equal to 11 would be the answer. So I'm going to start just by writing out the equation. And I can put my lines in. Okay, we're asked to make x the subject, so we're going to first of all add 10 to both sides. In fact, I'm just going to move all this over a little bit so I've got a bit more space. Okay, so we're left with m plus 10 on the left hand side, and we've got 1/7 x on the right hand side. Now to get rid of the 1/7, what I can do is just times both sides by 7. So 7 brackets m plus 10 equals x. So x therefore would equal 7 brackets m plus 10, but it says expand your answer fully, so we're just going to expand the brackets. 7m plus 70. So angles on a point add up to 360, and we are given the values of the angles but in terms of r. So we know that r plus 9r plus 20 will equal 360. So we've got an equation here we can solve. So first of all, let's add the r's together, and so that will be 10r plus 20 equals 360. Then we're going to subtract the 20 from both sides. So we have 10r equals 340. And then we're going to divide by 10 both sides. So we have r equals 34. So our answer is 34. The word truncated means that we just literally cut off the next number along. So if we imagine this is our number, we just cut it off. So it's not the same as rounding. We just don't change this digit at all. We just cut off the remaining digits. So the smallest number it could be before it was cut off is 79.500000. The largest number it could have been, well, it could have been 79.5999, etc. So that's the largest it could have been. So to do our error interval, well, the smallest it could have been is 79.5, and it could have been 79.5, and we'll call this x. But we're looking at any number that is less than 79.6. So any number that's less than 79.6. If it was 79.6, then when we cut it off, it would show as 79.6. So first thing I notice is the second equation isn't really in the normal format for doing simultaneous equations. So I'm just going to rearrange it so that we have it where we want it to be. And I'm just going to put my lines in so I can rearrange. So first thing I want is the x's and y's on the same side. In fact, actually all I need to do is take away 4y from both sides, and we get 5x minus 4y equals minus 7. Okay, so what we do now is we put both our equations down, so we can solve these simultaneously. So 5x minus 4y equals minus 7. And you notice the coefficient of the y is already the same, so we don't need to multiply anything. But the signs are different, and the d in different is the d in add. So we're going to add going downwards. So we're going to add everything. So we're doing 3x plus 5x, which is 8x. 4y plus minus 4y is nothing, which is good, because we want to get rid of that. And 47 take away 7 is 40. Alright, let's put our solving lines in. And we're going to divide by 8 both sides. So we get x equals 5. And we're going to substitute that value into one of the equations. I'm going to pick this top one. So instead of 3x, we're doing 3 times 5 plus 4y equals 47. Get my solving lines in. So that will be 15 plus 4y equals 47. And then we're going to take away the 15 both sides. And so it's 4y equals 47 take away 15, which is 32. Divide by 4 both sides, and we get y equals 8. And we can check that using this equation here. So 5 times 5 is 25. Take away 4 times 8, which is 32, is minus 7. So we know we've got it right. When it's said that y is inversely proportional to x, it means that y changes as 1 over x changes. And to write this in an equation, all we do is we just write y equals k over x. Now k is something we need to find. So what we need to do is find out what a value of y and a value of x are somewhere on the graph that would be formed from this, and we've got that in this question. So we know that when y is 7, then x is going to be 7.9. And what I need to do now is just draw my lines down. And what I'm going to do is I'm going to just times both sides by 7.9. And so we have k equals, and it'd be 7 times 7.9, which is 55.3. So we know that k is 55.3. So I'm just going to rewrite this equation here, or this formula here. But instead of k, I know that it's going to be 55.3. So our answer is y equals 55.3 over x. First thing I'm going to do is add these column vectors. So we're going to add the tops first, and then we're going to add the bottoms. So it's plus minus 14. And so at the top it would be minus 4, and 11 take away 14 is minus 3. Then I go pick a point on my shape, and the the top one tells us how far right we're going. So we know we're going 4 to the left because it's obviously a negative. So we're going to go 1, 2, 3, 4. The bottom one tells us how far up we're going. Well, it's going to be down because it's a minus 3. So 1, 2, 3. And we can do that for each of the other points. So 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. And when we've done that, we can join them all up with straight lines. And label the new shape B. So this question will probably need a Venn diagram just to make it a bit easier. So I'm going to draw a Venn diagram. You don't need to. If you can work out how to do this question without, you can do. But I think this is a really tricky question to do without a Venn diagram. So it says that they picked 2 activities. It was either painting, which I'll put as a P, and sport, which I'll put as an S. So let's start filling in the information it gives us. So 11 picked painting and sport. So that will go in the middle, because that is painting and sport. And 11 didn't pick painting or sport, so they can sit on the outside. Now here's the problem. It says twice as many people picked sport than painting as one of their activities. So it's saying that the total number in, and let's just show it, the total number in the sport circle is twice as big as the total number in the painting circle. Now, what we can do is we can say, okay, so if the painting we label as X, then the sport will be 2X. But if you look, we've already got a number already in the sport, that 11 there. So in algebra, this will be 2X, take away the 11 that we already know about. And the painting is the same. We know the whole thing is X. So what we're going to do is we're just going to take away the bit we know there, which is the 11, and it will be X minus 11. Now we know that there are 66 students in total. So what we can do now is add up all of the parts of the Venn diagram and get it equal to 66. So X minus 11 plus 11 plus 2X minus 11 plus 11, and all of that will equal 66. This is going to be some solving, so we're just going to put our lines in. Now here we've got x plus 2x, which is 3x. And if I put my tool right, there we are. And we've got minus 11 plus 11, minus 11 plus 11. Well, those just cancel out. So we're left with just the 3x equals, and then 66. We're going to divide that 3 both sides. So we've got x equals 22. So if we go back to our Venn diagram now, we can fill in the blanks. So instead of x minus 11 there, we've got 22 take away 11, which is just 11. Instead of 2x minus 11 there, we've got 22 times 2, which is 44, take away 11, which will be 33. So it says, find the amount that picked sport and not painting, which is this 33 here. When we multiply numbers, it doesn't actually matter which order we multiply them. So I can actually rewrite this as 7 times 9 times 10 to the power of 2 times 10 to the power of 9. 7 times 9 is 63. And 10 to the power of 2 times 10 to the power of 9, we add the powers, so it'd be 10 to the power of 11. Now here we've got a problem. It looks like standard form, but it is not standard form. Because standard form has to be a number between 1 and 10, but not including 10. And here we've got 63. So what I'm going to do is just quickly write out what number this is. So we've got the decimal point here. And you don't need to do this, but I find it a bit easier to show what we're doing. So here we've got 10 to the power of 11. So it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We fill these all out with zeros. And that's the number we've created here. A lot of zeros. Now, to make it a number between 1 and 10, not including 10, the decimal point, it needs to be here. So we want that to end up with 6.3 times 10 to the power of, well, let's work that out now. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to be 10 to the power of 12. Now you don't need to do all the working out I've just shown there. You just need to know when you convert that 63 into a 6.3, you need to add 1 to the power. It doesn't look like it, but we actually have a quadratic here. And the reason it doesn't look like it is because we don't have an x term. But as long as we have an x squared term and a number term, we definitely have a quadratic. And notice something about this second number. It's a negative version of a square number, and that will always be the case because this question is using something called difference of two squareds. And it's very, very simple to work out. What you do is you put down two sets of brackets and you square root the first term, well, that's just going to be x, and you put the positive and negative versions of the square root. So we're going to square root 121, which is 11. So we're going to put plus 11 and minus 11, and that's it. Now, when we expand that, and we're just going to quickly expand that now to have a look, it's going to be x squared plus 11x minus 11x minus 121. And notice that the two x terms cancel each other out, which is why we don't have the x terms. So the way this formula works is we have m, which is the final amount. The 2000 here is our initial amount. The decimal in here is our multiplier, and the power here is the amount of years. So the way multipliers work is they are the percentage divided by 100. So if we go the other way and times it by 100 to make it back into a percentage, it will be 102.9%. Now it says, what is the interest rate of the bank? Well, the interest rate is always going to be 100%, well, this 102.9% is 100% plus the interest rate, which will equal the 102.9%. So the interest rate is going to be the 2.9%. You always start off with 100%. So if I put £5 into my bank, I've got 100% of that £5, and then the interest rate is on top of that 100%. So our answer here will be 2.9%. So when we find the mean of something, we add the elements together and we divide them by the amount of elements. So here we've got 3 elements. So what we're going to do is add these together and then divide by 3. Now the problem is that the denominators are not the same, so we can't add them yet. But they're all factors of 45. So we're going to times top and bottom of the first one by 9. So we end up with 9k over 45. Times the top and bottom by 3. And so it would be 3 brackets k plus 1 over 45. And the last one is over 45, so we don't need to do anything for that. Then we can just add the numerators together. And I'm just going to expand the bracket here, so it's 3k plus 3 plus k plus 4. And then all of that over 45. And then we're going to do 9k plus 3k plus k, which is going to be 13k. And then 3 plus 4, which is just 7 over 45. So the sum of them is 13k plus 7 over 45. So to work out the mean, we need to divide it by 3. But instead of writing divide by 3, we know KFC, keep, flip, change. If you have a division, you keep the first fraction, you change the divide into a times, and you flip the second fraction. So a different and easier way of writing that is times 1/3. So here we just keep the numerator the same because we're timesing it by 1. And then the bottom we just times by the 3, which would be 135. So our answer is 13k plus 7 over 135. We know that vectors are written as the amount right at the top and the amount up we go at the bottom. So looking just at the x coordinates, we've gone from 5 to 7, so we've gone right 2. Looking at the y coordinates, we've gone from 6 down to 2, so we've actually gone down 4, so it's going to be minus 4. So to draw a box plot, we need 5 points. We need the lowest point, lower quartile, median, upper quartile, and highest point. Now we already have the lowest and highest points, so we can put those onto our box plot now. So the lowest point is at 0 and the highest point is at 30, as we can see on the cumulative frequency graph. So we need to now find out where the median is. Now the graph goes up to 20, the actual line goes up to 20, so the median we're going to find at 10. We're just going to draw a line across and down, and that looks like it is 17. So our median will be at 17, so we're just going to draw a line at 17. Get it just perfect, there we are. Okay, next thing, we're going to look for the lower quartile. So if the median we drew a line across at 10, the lower quartile would do it at 5, which will be here. So that's at 12. So we're just going to draw a line up from 12. Fill in this box, and we can actually fill it in with the lowest point. And lastly, we need our upper quartile, and we do that by adding the 5 and the 10 together to make 15. So we're going to draw a line across from 15 and down, and that's 23. So a line up from 23. Try and get this as nicely as I can. I need to move that line a little bit. Oops. There we go. And let's fill in the last bit, join it up with the highest point. And there's our box plot. When asked to simplify a surd, and this actually isn't a surd until we've simplified it, it means to get rid of, or to get the square root as small as possible. And the way we do that is we write down the factors of the 48 first. So we've got 1 times 48, we've got 2 times 24, 3 times 16, 4 times 12, and we've got 6 times 8. Now we want to look and see where the largest square number is. So we've got the 1 there, we've got the 4, and we've got the 16. So the 16 is the largest square number. And so what we're going to do is we're going to rewrite the root 48, but instead of root 48 we want to split it up into square root 3 square root 16, but always put the square number first. So I'm going to write it as root 16 times root 3. Now square root of 16, the reason we put the square number first is we can actually square root that. Square root of 16 is obviously 4. So it becomes 4 times root 3. And with surds, we don't actually write the times sign between an integer and the surd. So it's just 4 root 3. So to be able to solve this, we want to factorise the quadratic. And to factorise the quadratic, we're going to look at the coefficient of the x squared and the number left on its own. And we're going to multiply those together. So that we're looking at two numbers that equal, what is it, 2 times minus 36 is minus 72. And we're going to look at the coefficient of the x, minus 21, and we're going to look at the same two numbers need to add together to make that minus 21. So what we can do is we can write out the factors of minus 72, add all of them together to find out which one adds together to make that minus 21, or we can kind of do it in our head. So I'm thinking it's going to be 3 and minus 24. Let's just check that. 3 times minus 24 is minus 72. 3 plus minus 24 is minus 21, so that's correct. I'm going to write out this expression. Won't worry about the equation later. But instead of minus 21, I'm going to write plus 3x minus 24x. So I'm just going to replace it for what we've just found out. So it's going to be plus 3x minus 24x minus 36. And we might find it easier if we put the negative first. And I probably should have put the negative first, but let's keep going just in case we don't put the negative first. And we're going to do both of these separately. First two terms and second two terms separately. So we're going to factorise them linearly. So I'm going to take the x out of both of these, or divide the x out of both of these. Now here, don't forget the minus needs to be on the outside. So we've got minus, and it's going to be 12. And that's going to be 2x, and that's going to be a positive because it becomes a negative. Positive 3. The repeating bracket is one of our brackets. And then the bit left over, so the x minus 12 is our other bracket. So it's x minus 12 and 2x plus 3. To solve now, we get both of the brackets equal to 0. So x minus 12 equals 0. Get our lines in. And we're going to add 12 to both sides. So we've got x equals 12. That would be our first solution. And then we do exactly the same thing for the other bracket. So 2x plus 3 equals 0. Get it equal to 0 and solve it. And so we're going to take away the 3 both sides first of all. So we've got 2x equals minus 3. And then we're going to divide by the 2 both sides. So we've got x equals, and we can write it as a fraction, minus 3 over 2, or 1.5. And there we go. We have a expression with f of x in, and we're given what f of x is. So what I'm going to do is just write out this expression again, but instead of f of x, I'm going to write out what it says it is. It says it is 2x plus 5. And notice I've put it in brackets as well, because f of x is the whole of that, and then plus 4. We're just going to expand the brackets, and that will make 10x plus 25 plus 4, and then 25 plus 4 is 29. So the answer would be 10x plus 29. So we know that frequency density is proportional to frequency over class width. And so looking at this first bar, we've got a frequency of 12 and the class width is 10 wide. So the frequency density you would think would be 1.2, but if we look at it, it's actually 0.4. So we know that we're going to have to divide it by 3 to get there. So our formula is frequency density is the frequency divided by class width divided by 3. Okay, and so to find the next one, to find out what the frequency density is for the next one, we're going to do the frequency, which is 36, divided by the class width, which is 10, and then divide it by 3. And so when we do that, we get the answer of 1.2. And then we're just going to do the same with the next one. Frequency density is going to be the frequency, which is 12, divided by the class width, which on this one is 5, divided by 3. Then when we then do that, we get 0.8. So we're going to plot these on. So our next one is 1.2, so that goes up to 1.2. And then the last one's 0.8. When we add fractions or integers and fractions, we need the denominators of the fractions to be the same. And when we've got an integer, we just convert it to a fraction. And here we've got 9k, and we need to convert that to a fraction that is over k plus 9. And the way we do that is we get the 9k and we times it by k plus 9 over k plus 9. And effectively, k plus 9 over k plus 9 is just 1. So we're doing 9k times 1. So we're keeping it the same. We're keeping it as 9k. So what we do when we times a 9k or a term by a fraction is we times the top, the numerator of the fraction. So it's going to be 9k brackets k plus 9. And all of that over k plus 9. Expanding the brackets, we get 9k squared plus 81k over k plus 9. And so what I'm going to do is just feed that back in here. And so we've got 9k squared plus 81k over k plus 9, which is just that 9k bit, plus 11 over k plus 9. And whenever we're in this situation here, we just add the numerators. So it's going to be 9k squared plus 81k plus 11, and all of that over k plus 9. And that will be our answer. So let's put that in our answer field. So we're told in the question that y is inversely proportional to the cube of x. So we can show that by y is proportional, there's proportionality, inversely, which would be 1 over the cube of x. Now to convert that alpha, the proportionality symbol, into an equals, we need to introduce a constant to the right hand side. So we get y equals k over x cubed. And all I've done to the right hand side is multiplied it by k. Okay, now we need an instance where we know what y is when x is something, and here we do have that, or it should be the other way around. What y is, well, yeah, what y is when x is something. So we've got y is 10 and x is 7. So we're going to feed those numbers into this kind of equation that we've made. So it's going to be 10 equals k over 7 cubed, or 10 equals k over 343. Okay, and then we're going to multiply both sides by the 343. So times by 343 both sides to find out what k is. And I'm just going to swap them around just to give myself a bit more space. And we're going to have k on the left hand side here. So that'd be 3,430. So k is 3,430. So what I'm going to do is just rewrite this equation here but we know what k is now. So it's y equals 3,430 over x cubed. And that actually is our answer. So with all these circle theorem questions, there's multiple ways of doing it. I'm going to show one way, but if you've got a different way and you get the right answer in correct methods, then please feel free to use that. First thing I'm going to notice is we've got a lot of tangents touching radii. So we've got two radii here and here. And whenever we've got a tangent touching a radius, it's always going to be 90 degrees. And so I'm just going to show these all on the diagram as 90 degrees. And then we're going to say angle OBC equals angle OBA equals angle ADO equals 90 degrees. And we have to show the reasons. Most of the marks in this question will be for the reason. So it's going to be a tangent radius equals 90 degrees. And try and write out the full reasons. I'm going to just keep it a little bit contained, just so I can fit this answer all on the same slide. Okay, so the first thing I'm realizing is that there's a nice little quadrilateral here. And whenever we've got quadrilateral and we've got three of the sides, we can work out the last one. So angle DOB is going to be 360, take away the angles that we know, so 90 plus 90 plus 48. And the reason for that is angles in quadrilateral add up to 360 degrees. And so when you do 360, take away that, you get 132 degrees. So this is 132. But we also have this angle here, which is also angle DOB, but I'm going to call this kind of the reflex one. And to work this one out, we just do 360, take away 132. And the reason for that is angles on a point equal 360 degrees. And so we're going to do 360, take away 132, which is 228. So this is 228 degrees. Now we can also use the circle theorem to work out this one, because we've got an angle at the centre and an angle at the circumference, and the angle at the centre is twice the angle at the circumference. So angle DFB is going to be 132 divided by 2. Angle at centre twice angle at circumference. Okay, so when we halve that, so 132, and we're going to halve it, so that's 66 degrees. We should really put degrees on these. Okay, the next one we're going to work out is this angle here, which is angle OBF. There's no reason for this, it's just the whole thing is 90. We're taking away the 77, so that would be 13 degrees. So that's a nice easy one. And let's just put the 66 degrees on our diagram as well. And the final thing really here is that we've got a quadrilateral here, kind of arrowhead, and we've got three of the angles, 1, 2, 3, and we're looking for the third one. So angle ODF is going to be 360, take away all the angles that we know, so the 228, the 13, and the 66. And the reason being the same as before, so angles in quadrilateral add up to 360 degrees. And when you do that, you get the answer of 53 degrees. So this angle here is going to be 53 degrees. Now notice the format that it wants the answer does not have a square root at the bottom, so we are going to be rationalising the denominator with this. So I'm just going to write out the question, just so we've got a start. And notice here we've got this 6 plus root 2. Now you might think you rationalise the denominator by timesing top and bottom by root 2, and that would get rid of the root 2 there, but it would actually create a 6 root 2 at the bottom, so it won't rationalise the denominator. The trick here is, imagine that the bottom here is a bracket, and what you want to do is times top and bottom of this fraction by the same bracket, but with the different sign, the opposite sign in the middle. So instead of 6 plus root 2, it's going to be 6 minus root 2. So we're going to have 6 minus root 2. Okay? And when we do that, we can imagine that there's going to be brackets at the top as well. We've got 2 plus root 2 and 6 minus root 2 at the top. And then we've got the 6 plus root 2 and the 6 minus root 2. Now, the reason why we do that is you will see when we expand the bottom one, but I'm going to start with expanding the top one. And it doesn't really matter which method you take to expand it. I'm just going to use the grid method because it's a little bit clearer maybe. And so we've got 2 plus root 2, and we've got 6 minus root 2. So 6 times 2 is going to be 12, and that's going to be 6 root 2 minus 2 root 2, and then that would be minus and a positive is a negative, and then root 2 times root 2 is just going to be 2. And so when we add these two together, we're going to get 10. When we add these two together, we're going to get plus 4 root 2. And I'm going to now do the bottom one. So this one was this expansion here, and I'm now going to do this expansion here, and we're going to do it down here. And so we've got 6 plus root 2 and 6 minus root 2. So 6 times 6 is 36, 6 times root 2 is 6 root 2, 6 times negative root 2 is just negative 6 root 2, and then we've got a minus and a positive make them negative, and then root 2 times root 2 is just minus 2. And so when we add them together, we've got the 36 and the minus 2 there, so that would be 34. And then 6 root 2 take away 6 root 2 is just going to be nothing. So that actually expands to be an integer, not a surd. And that's why we picked the opposite sign, is because whenever we do that, we get rid of the root 2 and we just get a nice number at the end. Okay, so when we put those in, and we end up with 10 plus 4 root 2 at the top, which is our answer here, over 34, which is our answer here. And let's just make that a bit nicer. There we are. And that's our answer down here. Now, we're looking to see whether we can cancel at all. And if you look, we can actually divide everything by 2. So divide the bottom by 2, and we get 17. Divide the 10 by 2, we get 5, and we've got to divide all 3 terms by 2, so we get a 2 there. So we actually end up with 5 plus 2 root 2 over 17. So our missing numbers, looking back at the question, A would be the 5, B would be 2, and the C is 17. This question is all about completing the square, but we've got to do something first. We have a coefficient of the x squared there, and we want to get rid of that. Whenever we do the completing the square, we need to have just x squared on its own, ideally. So we're going to divide out that 3, and so we're going to have 3 brackets, and then we're going to have the x squared minus 10x, close brackets, minus 11. Then we're going to complete the square with x squared minus 10x. So we're just going to copy in that 3 brackets. And how we do this is we create a bracket and we put the x at the start minus half of the coefficient of the x, so half of the 10 would be 5, close bracket, squared. Now I'm going to leave that half done because down here I'm just going to, or across here I'm just going to expand that and show what that creates. So x times x, so that's the same as x minus 5
x minus 5. So we get x squared minus 10x plus 25. So notice here it creates this plus 25, which we've got to deal with. And we deal with that by removing the 25, which we do here. Close brackets, minus 11. So the blue parts haven't changed. The kind of turquoise parts are the completing the square bit, but the minus 25 just removes that 25 that the x minus 5 squared brackets create. Okay, so we need to get that minus 25 outside the brackets. So we're going to expand the brackets slightly. I'm going to leave the 3 on the outside of the x. In fact, let's keep the color scheme going. So we're going to have the x minus 5 squared bit there. 3 times minus 25, it's minus 75. And then we've got this minus 11 at the end. Okay, and we're very, very close to finishing. All we need to do now is sort out the minus 75 and the minus 11. And when we subtract those two, we get minus 86. Now the m part is going to be 3. The p part inside the bracket is going to be minus 5. And the q part is going to be minus 86. Here we've got a half on the outside, so our function's been multiplied by half, and all that's going to do is it's going to halve each of the y coordinates. So we've got a y coordinate here, and half of 6 will be 3. The 3 we've got here will be 1.5. The bottom of the curve here will be at 1, and you just go through and just halve all of the points on the graph. And when you do that, you should be able to draw in the graph, and it should look something like this. We'll try our best to draw it. And we're not looking for it to be absolutely perfect, but looking at that, you can clearly see that all of the y coordinates have been halved. So at the point on the graph where x is 12, it's this point here, and what you need is a ruler, and what you're going to do is rest it on so it becomes the tangent of that point. So I'm going to try my best to do it here. I'm just going to draw it out, and this is going to be my ruler. And I'm just going to move this into place. So we want that to be a tangent at x equals 12, which is about here. And then what you do is work out what the gradient of that line is. So I'm just going to draw a line across and up. And we know that gradient is the change in y over change in x. The change in y is 2, and the change in x is 1. 2 divided by 1 is just 2. So the gradient at x equals 12 is 2. Now notice it says x equals 12. It's a curve, so the gradient's constantly changing, but an estimate of the gradient at that point is roughly 2. And you just need to make sure you rest the ruler down, and then until you're happy with it, draw the line like I've done with the blue line, and then just work out the gradient of that. And if you just show all your working, show the examiner how you've come up with the value, even if your gradient's slightly off, you might still even be able to get full marks on some of the papers, if not 1 out of the 2 marks maybe. So I'm going to first of all just draw out the diagram a bit bigger, just so we've got a bit more space. And we're looking at going from B to M, and M is about here. Now the first thing to notice with M, and I'm just going to quickly label the other parts on, is that the ratio of A to M is 1 and M to C is 4. So the ratio is 1 to 4 between the two. And what is really helpful sometimes is just to label in the kind of section. So if A to M is 1 section, we've got 4 of the sections from M to C. So just put little notches there to show the 4 sections. And we can see straight away that A to M is 1/5 of that distance. That's why it's a nice, easy way to show that A to M is 1/5 of that distance. Let's just put a nicer 5, there we go. And so we're looking at going from B to M, but we can't go directly from B to M, we've got to go from B to A to M, and that's going to be the direction of travel. Now, we don't know the name of the road between A and M. In fact, we don't know the name of the road between A and C. We've got to first of all work out what that's called. So what we're going to do is we're going to go from A to C by going down here and then up here. So we can find out A to C is going to be going backwards down A, then up B. Now A to M is going to be 1/5 of A to C. Now if A to C is minus A plus B, that means A to M is going to be minus 1/5 A plus 1/5 B. Now we're asked for the vector B to M, and we know that that's going to be B to A plus A to M. We know B to A because it's labelled, it's just A. And we know A to M because we've worked it out down here. And it should be minus, let's get rid of that, because we know it's going to be minus 1/5 A plus 1/5 B. And so A minus 1/5 A is going to be 4/5 A. And then we've got the 1/5 B. So it's going to be 4/5 A plus 1/5 B. A normal sine wave starts at 0, goes up to 1 at 90, down to 0 at 180, down to minus 1 at 270, and then back up to 0 at 360. But here we're given a plus 45 inside the function. Now, a plus 45 actually does the opposite of what you think. You would think that it would move it right 45, but it doesn't. It moves it left 45. So each of these points we're going to move to the left by 45 degrees. So instead of at 91, this is now going to be at 45, 1. And each of these are just going to move left 45 degrees. Now 45 degrees is 2 squares. So it's just 2 squares worth of moving left. And so we get a really horrible start to this because we don't really know where it's going to start. It's going to start somewhere there. And then we've got a nice U shape and then down to here. These types of graph are not the easiest to do because they're stretched out, but make sure you have a U shape at the bottom there. And then we kind of guess here that it's going to go somewhere there. So in this question, complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.